Did you get to watch the videos for 2.9? Did you? You sure? How'd you like them? So, I thought they were very well designed, great acting. I sure like them. Anyway, but I'll be happy to go over really anything you want in here. You know, it can be similar to what you got to do there. But when we have combinations of x's and y's, so we said implicit differentiation. Kylie, you can see the board okay?
Looks good.
All right, perfect. So we kind of talked about this yesterday, taking the derivative with respect to another variable. This is with respect to a variable you don't even see up here, but we're gonna use implicit differentiation and just try and see a few examples today so that you can see that it's really just the chain rule. You okay? That's good. So, and then I do need to talk about the 90% rule. If not today, by next week. I'm just going to leave it up there. Okay, so that's from apple juice or some stupid thing. But, okay, so let's just pick one like number 17. Should we do that one? You haven't done those, have you? So because I have my videos, we can just problem solve, right? Like I can solve your problem. Hey, by the way, anybody like word problems? Raise your hand. Besides me, like everybody should raise your hand. When did you learn to not suck up to your teachers? Anyway, life's a word problem. Work it out. Tim Ryle. I've had that quote for a long time. Anyway, so if I've got x squared plus y squared equals 16, and we know the graph of that is a circle, right? But we also know that y is some function of x, correct? Y equals f of x. So the reality is, if I want to take the derivative, basically the question is this: find dy dx. I want to find dy dx, right? So take the derivative of y. I want dy dx. So the reality is, what do I got to do to both sides of the equation then? So this is the class participation part of the class. Take the derivative, right, with respect to what? X. So remember I said you can square both sides, you can add 5 to both sides, you can subtract 16 from both sides, but we can also take the derivative with respect to a variable on both sides. And since I want dy dx, let's just go ahead and take the derivative of this both sides with respect to x. Is that allowed? Okay, and then, so what's the derivative of x squared with respect to x? 2x, right? It's just 2x, right? It's just 2x. And then plus, now what's the derivative of y squared with respect to x? Well, y is really like f of x, so I'll kind of show this, but it's 2y. You act like it's okay, but y is a function of x, so what do we have to attach? The derivative of what's inside, or basically times dy dx, since it's a variable that's not an x. So we have to attach a dy dx. This is actually attached by what they call implicit differentiation. However, what is it really? It's just a chain rule. And I'll prove that. We'll just call it f of x up here and then go redo this again. And what do I get on the right side? 0. I get 0 because the derivative of a constant with respect to any variable is going to be 0, right? So we have this, and then of course we want to find dy dx. So what do? I'm going to get everything that's not a dy dx to one side and everything that has a dy dx attached to it to the other side. So in this case, I can subtract 2x from both sides, right? And I have 2y times dy dx equals minus 2x then, right? Remember, you get everything to the other side by taking the opposite side. So I'm doing adding 2x, we subtract 2x, right? Remember algebra? All right. Anyway, and then I've got 2y attached by multiplication, so what can I do here? Divide both sides by 2y. and I get that dy dx is minus 2x over 2y, and of course, this is equivalent to minus x over y, correct? Which should be the answer in the back of the book. So if you look up the answer in the back of the book, does anybody have that? We can see if that's what they have. Yep. Then what am I going to say? Then the book is correct. The book is correct because I know I am, sister. Right? Brother. Siblings. All right. Well, I know that's all right. I'm like so old, like I'm not really sibling, but I am your calculus father. All right. But anyway, if I go back and let's just instead of y, let's call it f of x. Okay, let's just put that in. So if I have x squared plus, that'd be f of x quantity squared, right? Equals 16. And if I'm going to take the derivative of that whole thing with respect to x, right? Then that ends up being 2x, right? And then plus, so the derivative of f of x quantity squared, this is just the generalized chain rule, right? We said it's n f of x to the n minus 1 power times f prime of x, correct? So this is going to be 2 times f of x to the first power, right? Which is just 2 times f of x times f prime of x. That's the chain rule. That's the chain rule, right? Generalized power rule, but it's a chain. That's one form of the chain rule is the generalized power rule. When it's a function to a power, this equals 0, right? Of course, you know, if we just go back, if y equals f of x, then what's f prime of x? It's y prime, or dy dx, right? Is f prime of x. So basically, I'm just substituting in, and if I rewrite it, this is 2x plus 2y times dy dx plus or equals 0, right? So it's just the chain rule. That's all this is. So the daunting part of section 2.9, I'm going to guess, is the what? The word problems or the trig, or both? Both. So let's do one with trig then, shall we? Pick an odd. Kind of from 17 through 32 in that area. $31. I don't know how to do that one. Can we do it? I'm just kidding. Oh, hey, you asked how I golfed yesterday. I was terrible before class, but doing a little calculus righted the brain a little bit. Well, I lefted the brain because that's your left brain working. I don't know if you take psychology, but you should because it's crazy. Anyway, but so I went out and like we actually set a record for 9 holes. Like my buddy and I, we did 2-hole best ball or 2-person best ball. That was fun. All right, and I didn't get in trouble. This is even better this time.
Wait, why didn't you get? What do you mean?
Because my wife knew I was golfing this thing.
Oh.
All right, 31. What is it? Can somebody read it, please?
X sine y plus y cosine x equals 1.
It's x sine y.
Yep.
Okay. So anyway, if I'm going to do this, what really, and it says find dy dx, right? We're trying to find dy dx. That's the whole goal is find dy dx. That's what we're looking for. So what do I need to do to both sides? Same deal. Derivative with respect to x, right? Of both sides, correct? And what we know is we're going to act like it's okay. If it's in terms of x, we're fine. We just take the derivative. But if it's in terms of y, we act like it's okay and then do what? Attach a dy dx by multiplication. It's just that simple. So anyway, but like if I do this, I do the left side, derivative of the sum of the derivative. So I got to take the derivative of x sine y first, correct? And if I do that, What rule do I gotta use?
Chain rule.
Well, I do, but before that, the product rule. It's a product. It's x times sine y, right? So I gotta use the product rule, which will end up including the chain rule, or basically implicit differentiation. So I'm gonna use the product rule for that one. So it's gonna be the first one, which is x times the derivative of the second one. What's the derivative of sine y? Cosine y, but since it was a y not an x, what do I attach? dy dx. By implicit differentiation, and actually by the chain rule, all right? Plus the second one, which is sine y, times the derivative of the first one. What's the derivative of x with respect to x? 1. Isn't that funny? It's the slope of the tangent line attached. The slope of the line, it's a line y equals x. That slope is 1, but dx divided by dx cancels out to 1. So there's a lot of ways. Or if you write x to the first power, 1, x to the 0 power, which is 1 times 0, which is also 1. So there's a lot of reasons why that's just 1. Correct? So anyway, this is the first part. Everybody agree? Plus the second part, the derivative of y cosine x. So why don't you try that one? Go. And I'll do the right side because it equals 0. Derivative constant. Did that one in my head. What do you got?
Y times minus sine x plus cosine x times dy dx.
Equals 0, right? So we get this. Y times first one times derivative, second one, y times minus sine x. Of course, that's in terms of x, so it's fine. Plus cosine of the second one times derivative of the first one. Derivative of the first one, you act like it's okay, is 1. And then attach a dy dx. In other words, the derivative of y with respect to x is what? Dy dx. Okay? So anyway, we get this. Now what do we got to do? We got 4 terms, really, right? So everything that has a dy dx to it, let's keep on the left side. So I've got x cosine y dy dx, and then plus cosine x dy dx. Those are on the left side. And then I'm going to get everything that doesn't have a dy dx attached to it to the right side, to the other side. So instead of plus sine y, what do I have on the right? I want it on the other side. Minus sine y. So I add, you subtract, right? And then instead of minus y sine x on the left, plus y sine x, right? Plus y sine x. Okay? Because this is like minus plus a negative y sine x on the left side. So to get it on the right, you undo, subtract, and you add. Right? Basically, same term, opposite sign is how that ends up working out. Now, what do I got to do though? I want to solve for dy dx. So I got dy dx here and a dy dx there. If in doubt, factor it out. Absolutely. Okay, so I pull that dy dx out front. And what's left? X cosine y plus cosine x, right? And that's going to isolate and get that dy dx by itself. Okay, and that equals minus sine y plus y sine x. Okay, and then to solve for dy dx, you're multiplying it times that quantity, so to undo that, you divide both sides by that. So divide both sides by x cosine y plus cosine x. Instead of drawing it out underneath, I just, instead of multiplying by that on the left side, divide by it on the right. Okay, now, we do want to see if anything will cancel out. Sometimes we can factor something out and makes it look really nice, but we can't really factor anything out there, can we? So this should end up being the final answer. Now, it doesn't matter if you write minus sine y plus y sine x, or if you write y sine x minus sine y on top. It doesn't really matter, it's equivalent. But is this an equivalent version of what the book has? That's no more complicated. Yeah, then the book is correct, right? So we really found a pattern for implicit differentiation. The only thing is, the reality is it's the chain rule, right? Because y is any function of x. What's nice about implicit differentiation, in the previous sections, when you used the chain rule, you knew what f of x was. F of x might have been the square root of x squared plus 3, for example. But x squared, or excuse me, f of x could have also been sine of x, right? Could have been something like that. It could be any function. So y is any function of x. So if I have x times sine of that function plus that function times cosine of x equals 1, whatever that function is, if I wanted to, I could just plug it in for y down here. So if the function was actually the square root of x squared plus 1, I could just plug it in for the y's down there, and then you're done. If it happened to be sine x, it would be minus sine of the sine of x plus the sine of x times the sine of x, which ends up being sine squared x, right? So whatever function, y is any function of x. So really we're doing this in general for any function of x. So y is any function of x. So that's really what makes it nice, but instead of calling it f of x and have f of x bracket to a power and stuff like that, we can just have y to a power, take the derivative with respect to x. So that generalized power rule that we had, instead of f of x to the n power, I have y to the n power, and I take the derivative of that with respect to x. What we get? We get n times y to the n minus 1 times derivative of what's inside, which we could put y prime, but what are they writing it like in this section? dy dx, right? Instead of y prime or f prime of x, we're writing dy dx. But they're all different notations for the derivative. And what is a derivative again? Do we remember? It's the slope of the tangent line of a curve at a point. What else is it? I call it IROC. Instantaneous rate of change of a curve at a point, right? Okay, so that's what a derivative actually is. And if we did a graphical interpretation, it's the slope of the secant line as you approach one of those particular points, right? From both sides. So it's actually a limit. So do you realize why we spent so much time on limits? Because derivatives wouldn't exist without limits, right? And calculus wouldn't exist without what? God, thank you. Isn't it great for me to be able to say that? I say it in my other room too. Like I said, what are they going to do, fire me? You can see how replaceable we are. Nobody wants this job. All right. I get paid, not a lot, very little, but I get paid to come and do calculus problems? Are you kidding me? What a career. All I got to do is hope you don't infest me with your COVID and, you know, that I survive at my high stage. All right. What other one? You want to do a word problem or something?
Yeah.
Let's do one that has time in it. Let's do one that has time. I didn't assign number 54 to turn in. I don't understand why I wouldn't have assigned that. I don't have my assignment sheet. So
On there.
54 is on there?
Yeah.
Perfect. And so I don't want to do that one. You can do it. You know, number 46 is kind of neat. Let's do something like that. Let's start with the number 43 or 45 you pick. That way I want you to feel involved with the class, so 43 or 45.
What?
Which one?
A second.
Oh, now, you don't have to look at them, just pick one. Pick a number, any number. 42 or
45.
40, 45. If you're Irish, it's 45.
Okay.
Right, what is it? I can't read. I don't have my bifocal contacts in today either. But I can see you much better. I like seeing you better than seeing like the board or the book.
X cubed plus Y cubed equals 1. And show that d2y over dx squared equals negative 2x all over y to the
Yeah, show this?
5th. Yep.
Okay, there, I just did, boom. It's obvious. QED, the rest is obvious. That's Latin. Well, so what, this is d squared y over dx squared, what is that? What is that? Second derivative. Second derivative of y with respect to x, that's how you say that in verbiage, right? That leafy green stuff that comes out of your mouth. Okay, anyway, by the way, with x cubed plus y cubed factor, not that it has anything to do with this problem. Sum of cubes factors, remember, cover up the cubes, x plus y, and then it's times x squared minus x times y plus y squared. Like, you know that, right? Like, just because you got to, calculus without having to know stuff, those days are over, right? Like, dude, you go to college, you get arrested, they'll be like, what's your name? I don't know. Where are you from? I don't know. You'll be in jail. You need to know stuff, right? Do you know your driver's license number? I'm just going to randomly pick on somebody that I don't usually pick on. Isaac. He's looking it up. If you don't know where to look it up except on a quiz or test, then you're screwed. Perfect. It's an awkward combinations of numbers and letters, and who likes those? Calculus people, math freaks. I don't even like it. Do you know that as a math person, I was really good with numbers? Really good with numbers. So good with numbers, I was bad with people's names. So when I was in college, I dated this gal that's not my wife. It wasn't real serious. It kind of was for me because, I didn't date very many people. I was busy. But anyway, I got busy with football and studies and everything else. And then it was springtime. So this was like in the fall, right? And, go home for Christmas break, kind of fall apart, whatever. And then it's spring, the sun's out, the birds, the bees, whatever. And I see this guy walking across campus. I should ask her out again. There was only one problem, Kylie. What do you think that was?
I don't know.
I didn't know her name. Now, you can think I'm just a jerk, like all guys are jerks, right? Well, maybe I was, I don't know, but I didn't know her name. But what did I know, Carter? I knew her phone number.
That's
I
creepy.
didn't know her, so that's creepy. That's creepy.
That's very creepy.
But I knew her phone number, and I yelled it out across the campus, like she's across the quad, and I yelled it out, and she's like, looks up in the air like it's a gift from above, and she's like, that's my phone number. And then she looks over at me, and I'm waving at her just like I saw Trevor. And I'm like, hi, Trevor! This morning, coming into the hallway. Yeah, he wishes I wasn't there. On purpose. But anyway. It's not waving at me. Not care about. All right, but anyway. Enough about me. Let's go back. D squared y over dx squared. All right, so what do we got to do first? If we need the second derivative, what do we need first? First derivative. Can you do that? I'm going to take the derivative of both sides with respect to x, and what do we get? X squared plus 3y squared times dy dx equals 0. I love it when it equals 0, right? It reminds me of all my friends. So anyway, we got this. Now what? Well, get it on the other side. So we got 3y squared dy dx equals 3 minus 3x squared, right? So get everything that's not a dy dx to the other side. And then we're going to divide both sides by 3y squared, right? And what do we get? We get that dy dx is equivalent to minus x squared over y squared, right? That's dy dx. Everybody agree with that? And then all I got to do now is what? Take the derivative of that with respect to x to come up with a second derivative. So I'm just going to rewrite this up here. We have dy dx equals minus x squared over y squared. And I'm just going to take the derivative. Can you see green okay? Charlie?
Sorry, you cut out. What'd you say?
Can you see the green okay? Or not?
What's written in green?
d dx.
Yeah.
Okay. Anyway, d dx equals dy dx, or no, I'm taking the derivative of both sides with respect to x. So what do I get on the left side? I get the second derivative of y with respect to x, right? So d squared y dx squared, correct? It's second derivative, and what's it equal? What do I have to use on the right side? Quotient rule, right? It's a quotient. So, I mean, I'm going to have to use implicit differentiation. In other words, I'm going to have to use the chain rule within there because there's y's in there. There's y's guys in the denominator, right? But anyway, I got to use the quotient rule. So what is the quotient rule? Bottom one, which is y squared, times the derivative of the top one. With respect to what, though? X. So we're fine. So you just say, what's the derivative of the top one? Minus 2x, right? Minus the top one, which is minus x squared, times the derivative of the bottom one, which is what? 2y times dy dx. Right? All over the bottom one squared, which is y squared squared, which is y to the fourth, right? Did I add or multiply those exponents? Multiply. That's the amen rule. A to the n power is a to the m times n. That's the amen rule. Can I get an amen? Amen. Can I get an hallelujah? Hallelujah. I did that in the spring last term for, well, not last term because we got shut down with COVID, but 2 springs ago, I've done this. This is you're my fourth group of tempered good kids, right? And I said, can I get an hallelujah? And they're like, Lent. You can't do that. I'm like, oh goodness. All right. Add it to the list of things I need to go confess again. All right, but anyway. So we go here, what do we got? So we're getting closer, right? Well, what I got? I got minus 2xy squared plus 2x squared y, because minus minus is plus, and then dy dx all over y to the fourth. Okay, well, what do I got to do? That doesn't equal this. Huh?
Move the dy dx.
Well, I don't want to move the dy dx this time because I want to find out what d squared y dx squared is. Do I know what dy dx is?
Yes.
Substitute it in. So I'm just going to take this purple thing and plug it in for dy dx, right? And if I do, what do I get? So I'm going to get, this is minus 2xy squared plus 2x squared y times minus x squared over y squared, and then all over y to the fourth power, right? So what can I do? How do you simplify this thing? So this is d squared y dx squared, right? I've got a denominator in there, so I talked to my 8th graders taking freshman algebra, right? If you have a fraction within a fraction, I don't like fractions within a fraction. That's called a complex fraction. So how do you get rid of it?
Copied.
Multiply numerator and denominator by the least common denominator, which is y squared, right? And I multiply through by y squared. So I'm going to go back I'm running out of room here, so I'm gonna keep the answer up here because I know what I'm trying to end up with. So anyway, if I do that, I multiply, so I'm gonna show this. I'm gonna multiply numerator and denominator by y squared. And if I do that, I get minus 2xy to the fourth. Remember, the distributive law, I gotta multiply times each term, right? And then it'll cancel on the second one. And then I get minus 2x to the fourth y, correct? Does everybody agree with that or not? So you gotta multiply y squared times each term. Well, it'd be y cubed, but then divided by y squared, right? So I'm gonna cancel that. All over y to the sixth. So I think I did, and once again, this is still d squared y dx squared, right? That still doesn't look like that. So what might you want to do now? If in doubt, factor it out, right? So pull out what we can. So I can pull out a minus 2x, right? And y times what's left? Y cubed. And then what's left in the second one? Plus x cubed all over y to the sixth. Now, I can see real quick, I'm getting closer, I can see real quick here that the y, one of the y's cancels, right? And I'm left with y to the fifth power. Everybody agree? Well, so it's close. So I've got minus 2x on top, and I got y to the fifth on the bottom. The problem is I got this y cubed plus x cubed, so what I do wrong? Huh? Why? Well, before I took the derivative, I had my original function given that said that x cubed plus y cubed equals 1. So instead of x cubed plus y cubed, I know that equals 1 because it was given. And then what do you end up with? So this is equivalent to minus 2x over y to the fifth. So it's nice that they gave you the answer. Do you think that I will give you the answer that you're trying to come up with on your test or quiz? Well, yeah, you know, you assume I'm a nice guy, and I am outside of the classroom. Right? Job suffered. He was a suffering servant. He offered it up, man. So you're going to suffer in calculus at times. Offer it up. Offer it up. Help others that need it worse than you. You know, my wife accidentally with your phone, and I don't mean to pick on my family. Anyway, she accidentally hit both buttons. What happens? Emergency, right?
Oh, if you click it.
I don't know how she did. She didn't even know how she did. It was going on. Couldn't get it shut off. She's like, right, I'm going to get called. I mean, the emergency button, you know. She's like freaking out. I'm like, honey, it's a lot better than actually having an emergency. So sometimes it's how you think about things, right? So since I'm probably out of time to do a word problem, I want you to try and get everything done with 2.9, because really you have my videos for the word problems too. The only one I didn't do on like is where you take a derivative with respect to t, but I kind of did that yesterday, right? And then I do have a word problem video that should help you with number 54, I hope. Okay, if you can't get it, reach out. I'm okay with that, right? So I give you the benefit of the doubt, but that's only assuming that you're giving hard best effort all the time. And what is hard best effort all the time meaning? Watch Facing the Giant Death Crawl. It's a 5-minute video. Okay? So that's giving your best effort all the time. We're doing it academically, right? So I do have a, want to wait on the 90%? What time do we get out? Like the bell didn't even ring till except like me, Kylie. But if you got a question,
What?
I'm going to talk about the 90% rule next week because the next week's more appropriate anyway for that. Any questions? Think you're good? Okay, so I've got everybody's 2.7 as well as 2.8 perfect. So I'll open up 2.7 and 2.8 so that you can see the answer keys and stuff too. But Have a good weekend, and we'll meet Monday and Tuesday, but not Wednesday. Or Thursday or Friday, even better. Okay? So give me some really valiant effort before, before Thanksgiving, so that you can relax more over Thanksgiving. Okay? See ya.
Are you teaching stats next semester? Is that a different person?
It's right now it's not me, so not me. So, all right. Any
Okay,
questions?
bye.
All right, see ya.